Hello everyone, welcome to Mechanical Vibration lecture. In this lecture, we will discuss about the response to arbitrary excitation. So if we discuss or if we consider this system, then the dynamic equilibrium equation or governing equation for this system is can be written as mx double dot cx dot plus kx is equal to ft, and initial conditions are these: the displacement at t is equal to 0 time is 0 and velocity at t is equal to time is 0. So if we apply the harmonic excitation to this system, then we know the response of this system. So harmonic force can be something like this. So we till now we have discussed that the response of this system when they applied some harmonic force, but instead of harmonic force, if we apply some random force, then how to find out the response of this system, that we will discuss. That random force can be something like this. So that can be a arbitrary excitation. So now we'll discuss how do we find out the response from the principle we already discussed in the single degree of freedom system. So for the single degree of freedom system, we have discussed the response of the undamped system and damped system due to free vibration, and we'll use that knowledge to find out the response of arbitrary force. So first of all, we'll draw the arbitrary force. So let us say this is ft and this is t time. So at any point t equals to tau, we take force for d tau interval. So impulse, this is known as impulse at fixed time. Impulse at fixed time tau is f tau into d tau. This is known as impulse. So impulse can be, and you can define the impulse as very large force acting for a small time with finite interval. So that is known as impulse. So we can say impulse is this is tau, this is for d tau. So this is impulse, and response because of this impulse is, or if we take the value of this impulse as unit, if we take this value, so this value, the area of this, which is f tau up to this multiplied by d tau is 1, then this is known as unit impulse. This is known as unit impulse. So response because of this unit impulse is can be represented as, because till tau time there is no response because there is no force, and tau theta equals to tau time, there is a unit impulse, and response because of this is something like this. So this can be represented as h t minus tau, because before tau there is no response, or you can say during this there is no response. and after this there is a response because of unit impulse. So now according to Newton's law, we can say applied force is equal to rate of change of momentum. Rate of change of momentum. And so we can say F equals to mx2 dot minus, this is mass multiplied by velocity is momentum, and mx1 dot over dt. So this is force momentum principle. And if we apply F multiplied by dt is equal to m delta x dot, so this is force multiplied by dt is known as impulse. And for unit impulse, you can say unit impulse is, if this f dot dt is equal to 1, then this is known as unit impulse. Here, where we can say the area of this is unit, then this is unit impulse, and response against this unit impulse is h t minus tau, and this is also known as impulse response function. This is known as impulse response function. So from here we can write 1 equals to m delta x dot. And as we know that before time tau there is no response, so you can say the because of unit impulse the initial velocity is 0, or we can say let assume initial velocity at 0, and as the impulse is applied, unit impulse is applied, there would be some velocity. That velocity we are going to find out. So we can say the 1 equals to m multiplied by x dot at tau time minus x dot at before tau, which is 0, or initial velocity which is 0. So we can say x dot at tau time is 1 by m. So this is the velocity generated by, or you can say velocity generated by unit impulse at t equals to tau time, and the displacement at that time is 0. So initial condition for this becomes x dot at tau is equal to 0, and x at initial displacement was 0. So these are initial conditions created by unit impulse, and we know that the response of or you can say a unit impulse causes free vibration due to initial conditions. And those initial conditions are x dot at tau is equal to 1 by m and x at tau is equal to 0. And we know that the response because of initial conditions for the damped free vibration, damped free vibrations, xt is e raised to power minus zeta omega n t x naught cos omega dt plus x naught dot plus zeta omega n x naught over omega d sin omega d. So this is the damped free vibration, or undamped free vibration can be written as undamped free vibration. We can write undamped free vibration because of initial conditions can be written as xt is equal to x naught cos omega n t plus x naught dot over omega n sin omega n t. So now let the displacement or response due to unit impulse at any time tau is h t minus tau, because before tau time there is no response or response is 0. So now one unit impulse, you can say one unit impulse generating h t minus tau response. And before tau time, there is no response. There is no response. Graphically, we can say this is tau, and at tau time, this is unit impulse, and this is the response h t minus tau, and this is unit impulse. So and initial conditions are, as we know that initial conditions, as we discussed, x naught is equal to 0 and x naught 0 initial velocity, or you can say x at tau is equal to 1 by m, or this is 0. So displacement and velocity at tau is equal to these are. So now you can say the response because of unit impulse to the damped free vibration, or damped free vibration. Damped free vibration, this can be written as h t minus tau is equal to e raised to power minus zeta omega n t minus tau. At the place of t, we are replacing t minus tau, because before tau time there is no response, and this becomes 0 plus x naught at tau time plus 0 over omega d, and this becomes sine omega d t minus tau. This shows that, this tells us this shows that if time scale is given till time tau, till time tau, there is no response. There is no response. After that, response starts. So we can say time must be, time t must be greater than or equal to tau. Or you can say this is something already we have discussed in the graphical form. This is something like, this is till tau there is no response, this is tau, and after tau there is response. So response due to unit impulse is for damped free vibration, this is given by this, and for damped vibration, for undamped free vibration, this is given as h t minus tau, because we are writing because of unit impulse, this is 1 by m omega n sine omega n t minus tau. So these both are same. If in this, if we replace the zeta equals to 0, then this term becomes 1, and this omega d is nothing but it's a omega n under root 1 minus zeta square. If we replace zeta equals to 0, then this becomes omega n only, and x naught tau is 1 by m. So this becomes, again, this omega d becomes omega n. So these both are same if we replace the zeta equals to 0. So now the response because of unit impulse, we know that, or you can say the response because of unit impulse, this is force, and at time tau this is unit impulse, ft into d tau is 1, response of, this is tau. So this is the response of undamped free vibration, and this is the response for damped vibration. And for this time, t must be greater than or equal to tau. So now the response to the arbitrary force. So this was the response to the unit impulse. So now we can say the impulse at time equals to tau. Impulse is ft multiplied by d tau. This is impulse at tau. So now you can write the response due to impulse. So because we can say the total arbitrary force, you can say the total, or you can say arbitrary force is nothing but it's a series of impulse values of impulse of different values, different magnitudes, impulse of different magnitudes. So arbitrary force is nothing but it's a series of impulse of different magnitude values. So we know at this time we know the response due to unit impulse, and now we can find the response due to impulse. So you can say response due to impulse is, that can be written as dxt. We are writing it dxt because we are writing for one impulse, and total response or total arbitrary force is a series of impulse. So later on we can integrate it and we can find out the total response. So response due to impulse is dxt is f tau into d tau. This is the value of impulse at tau time. This is the value of impulse at tau time multiplied by response because of unit impulse, that is ht minus tau. So this is response because of unit impulse. And now the response due to arbitrary force, response due to arbitrary force, because arbitrary force is a series of such impulse. So now we can integrate this response over total xt is integration over total time 0 to t dxt, or you can 0 to t. This is f tau multiplied by h t minus tau multiplied by d tau. So this is the response because of arbitrary force. So this is known as convolution integral. Convolution integral, or also this is known as Duhamel's integral. So this is very powerful tool to find out the response of any arbitrary force. So in summary, we can say just by decomposing the force into the series of, so you can say just decompose the arbitrary force into series of impulse, then find out the response for unit impulse, then multiply the value of impulse, then integrate the response due to impulse over the time domain. We can find out the total response against the arbitrary force. So now you can write the response of, I'll write here, of damped free vibration because of arbitrary force. This is xt is equal to 1 over m omega d integration 0 to t. This is f tau e raised to power minus zeta omega d t minus tau sine omega d t minus tau multiplied by d tau. So this is the complete response of damped free vibration against the arbitrary force. And similarly, you can write the response of undamped. We can write the response of undamped system to impulse. So that can be written as xt is equal to 1 by m omega n 0 to t f tau sine omega n t minus tau d tau. So graphically we can understand, if there is a arbitrary force, so suppose this is our first impulse, this is second, this is third, this is fourth, and this is the response because of first impulse, and this is the response because of the second impulse. Similarly, if this is the response because of the third impulse, so total response x is summation of all these, or you can say superposition of these all. So that would be something like this. So this is how we can find out the response of the system for arbitrary excitation. So thank you. In the next class, we'll discuss few special cases of arbitrary force.